So we are on the third lesson, basically systems of non-homogeneous. Last time I've given you something like this, about the expression in which it is written, the derivative matrix is equal to the coefficient matrix times the variable matrix plus the B matrix, or this is a function of t. If it's non-zero, it is non-homogeneous. If B is zero, it is considered to be homogeneous. Now, remember that before, in the homogeneous types, our answers are basically in this form, the one on top. But then for non-homogeneous, the final answer would take the form of xc plus xp. Do you recall what's xc? It's the complementary solution, whereas the XP is the particular solution, right? Okay, so in this case, note at the bottom, note that A and B are functions of t, because C1 and C2 are just constants. So what we do here is, if we arrive at a certain complementary solution, we propose a particular solution. And then the proposed particular solution is in terms of A and B. So you replace C1 by A, C2 by B, but A and B are both functions of t. And then how do we solve this? We use variation of parameters. Let's use the Kramer's rule. So for example, guys, you have something like this. Basically the same rule in arriving at xc. However, the way we solve it is we treat this as a homogeneous type first. So still, we express this in terms of a minus mi, right? Get the determinant, equate that to 0. So this is still your auxiliary equation. So we can solve for the roots of the auxiliary equation. So these are the eigenvalues that we have. Now that we have this, you already know. You basically plug it in to solve for to obtain the characteristic equation, right? For m equals 2, a minus mi was 0. So here, you'll notice that basically they are the same. Negative 2c1 plus c2 is 0. So we don't need to write the second line. But what we can say is that c2 is always equal to 2c1. So if I say that c1 is equal to 1, my c2 will be 2. Therefore, for m equals 2, I'm already able to obtain my solution. Now, for m equals 1, still substitute the m here. So you'll arrive at negative 1, 1, negative 2, 2. So you'll notice that they're basically multiples of the one on top. So let's just use the top. Negative C1 plus C2 is 0, or C2 is equal to C1. If C1 is 1, C2 is also 1. So for m equals 1, C2, 1, 1, e to the t. So no problem in solving for the complementary solution. This is the complementary solution that you have. So, as I said, once you arrive at this one, you propose a particular solution. And then do take note that A and B are functions of t. Take note ha, hindi sila constants. So it would have the same form as the one on top. So what if you interchange them? It's okay. So that means if A was partnered with the 1, 1, you have to be consistent. It has to always be partnered with 1, 1. Okay. So do you remember this? What do we do? Diba? Copy the first, which is the A and 1, 2. Derivative of the second, kasi take note that since A and B are functions of t, copy the first, derivative of the second, e to the 2t times 2. So, ayun. Plus copy the second, including the 1, 2, kasi 1, 2 is basically a constant. 1, 2, e to the 2t, derivative of the first, which is a prime. And then the same. Copy the first, derivative of the second, copy the second, derivative of the first, which is b prime. Now, you're finished with this. This is what you call x prime p. So we plug it in the one on top. Because look at the given problem. This is the xp, this is the x prime p. So you'll notice here that x prime p, kasi take note of the form, isn't it that x prime ax plus b? Therefore, I can say that similarly, xp prime is a xp plus b. So x prime is this one, the one that we were able to solve for, that one, is equal to, ito yung a di ba? Look at the one on top, a x. And instead of x, write that as xp. So a xp plus b. Now, recall that in solving this, this is always row by column. So 0 times 1 plus 1 times 2 is 2. Negative 2 times 1 is negative 2. 3 times 2 is 6. Negative 2 plus 6 is 4. That's why you have 4 at the bottom. Next. What we do here is, you'll notice that you'd be able to cancel out some of the terms. As I look at this, 2 times 1 times 1 over 1, 2 is basically 2, 4. There's that at the bottom. So all the time in variation of parameters, you'll notice that what will be left for you is always the primes. Diba? This one will cancel out. That one will cancel out. So the prime will be left. You'll end up with this line. So from here, we need to solve for the A and the B, not the A prime and the B prime, Need to solve for A and B. How do we do that? We use the Kramer's rule. So what we do here is, from the given final form of the equation, which is here, we translate that into an augmented matrix form. So this one, tatanggalin lang natin yung A prime. So that's 1 times e to the 2t, 2 times e to the 2t, that's this one. 1 e to the t, 1 e to the t, that's this. And then e to the t, 2. Okay. So that means the coefficients are on the left, the constants are on the right side of the vertical bar. And then, do you remember that if you're solving for the a prime, isn't it that a prime is this? The e to the 2t and the 2 e to the 2t. What you do here is, if you're solving for a prime, this is your a prime, this is your b prime, and this is your basically r of t, functions of t. So since you're solving for a prime, the terms under, or the elements under a prime, will be replaced by the functions of t, by the ones on the right. Kaya naging e to the t over 2. And then solve for the determinant. So e to the t times e to the t is e to the 2t minus 2 e to the t. So okay na tayo dito. And then at the bottom, e to the 2t times t is e to the 3t minus 2 e to the 3t. So here at the bottom, what you'll have is basically negative e to the 3t. So e to the 2t divided by e to the 3t is e to the negative t. Negative 2e to the t divided by e to the 3t is positive 2e to the negative t, negative 2t. So you'll have this. But then take note, guys, that this is still your a prime. What I need to do is solve for a. So here, you'll have this as a function of t. Integrate that. So you'll end up with negative e to the negative 2t plus e to the negative t, right? And then I just interchange the order so that the positive is the one in front. So now we have solved for A. Let's try solving for B. So for the B, since we're solving for the B, we will replace the column that contains the elements from B prime with e to the t and 2. Kaya ito. But then at the bottom, di ba remember for Kramer's rule? For example, in Kramer's rule, x would be d with x replaced over the determinant. Y is the determinant with y replaced over the determinant d. So, eto, ni-replace ko yung A, kaya, let's just say X. Yung column ng X or yung column ng A, ni-replace ko siya by this, the coefficient. So, here, basically, in order to solve for B, it's the determinant with B replaced over the original determinant. The original is this one. So, you'll end up having this as an answer for B prime. And then again, from here, let's solve for the B. You'd be able to solve for this one. So, hindi pa tayo tapos ng answer kasi B pa lang siya. You have to plug it in now. Kasi, di ba, remember, this is your XC, this is your XP, you plug in A. So, ganito yung itsura niya. So, some of you might ask, how do we express this as X and Y? Okay, ganyan siya, di ba? If you want to express that as X and Y, first, let's arrange this. You can see that the final solution would be C112 e to the 2t plus C211 e to the t plus ito e to the negative t at saka e to the 2t. Can I combine them and say e to the t na lang siya? Minus 1. And then that is 1, 2. I factored in the e to the 2t, combined that with the terms na puro may e. And then in here, plus 2t e to the t plus 2, 1, 1. Pero, naka-x and y magkasama pa siya. So, if you want to solve specifically for x as a function of t would be lahat ng nasa top. C1 e to the 2t, C2 e to the t, plus e to the t minus 1, plus 2t e to the t plus 2. Whereas yung y natin would be 2c1 e to the 2t plus c2 e to the t plus 2 e to the t minus 2 plus 2t e to the t plus 2. And if you want, you can combine those similar terms. Lahat na may e to the t, lahat na may e to the 2t, pwede nyo pagsama-samahin. Kasi yung mga constants that could cancel, you may cancel them. So it's not that difficult. Let's go to another one. Kasi the other one is basically just a sample of non-homogeneous. So let's go to another one. But then the roots are complex. So the matrix for A is given. The matrix for B, the elements are given as well. So let's convert that into the form x prime equals ax plus b. So it's this. So again, we do the similar approach. A minus mi equals 0. So here, 2 minus m, 1, negative 4, 2 minus m equals 0. Don't mind the coefficients of b yet. So let's solve for the roots. M here gives us 2 plus and minus 2i. So with this, you know that the A has a value of 2, the B has a value of 2. Okay? Can you dictate to me nga, what's the general form of the answer when you have complex roots, x is equal to what? Ito siya, di ba? C1 tas real cosine BT, ito e to the 80, e to the 80, C1 real cosine BT minus imaginary sine BT plus C2 imaginary cosine plus real sine. Ito laging aalalahanin nyo. Okay, so we have this, the first root. And again, for complex roots, some of you might ask, Sir, bakit pag complex roots, isang beses lang kami nagsosolve? We're not solving for the second one, the 2 minus 2i, because it has already been accounted for. Kaya dalawa nga to, may isang plus, isang minus na nagbaliktad ng partner in order to account for the conjugate, di ba? Conjugate roots. Okay, so in here, if C2, if C1 is, so if C1 is equal to 1, C2 would be 2i. Tama? So, how do you write that? Ayan o, 1, 0i, 0 plus 2i would be the form of the answer. Di ba? Madali lang naman, no? So, negative. Ito, you understand naman, di ba, what to do here. And then what happens, guys, is from here, you give me the elements of C. So 1 plus 0i is 1 ang real part, imaginary is 0. Ang real part sa bottom is 0, imaginary is 2. Diba the coefficients of the imaginary? You don't need to write the I anymore. With that, you have to take note that in here, note that the A that we have is 2, B that we have is 2. Diba ito? 1, 0, and 0, 2. So that is for the real. This is for the imaginary. So e to the 80, ayun na, the 2, is C1 real part, 1, 0, cosine of B, which so happen to be 2, minus imaginary sine BT, plus capital C2 imaginary cosine BT plus real sine BT. Okay, now this is still XC. Take note that this is non-homogeneous. If it's non-homogeneous, what's happening is we have to propose an XP. So the XP, C1 and C2 becomes A and B. Tinatry natin iwasan yung letter C kasi C ginagamit natin ang daming beses ng C. So ginagamit natin A, B, D, E, F, G, ganun. Pero wag na sanang letter C. So, for this one, let's differentiate. Okay, di ba? So, the derivative would be copy the first, derivative second, copy the second, derivative the first. However, just like what I've shown you here on this slide na, di ba kasi on this slide from what you obtained here, we differentiate. Nung differentiate mo, those that don't contain the prime will actually cancel out. Therefore, some of you might ask, Sir, pwede bang skip ko na yung step na yon? Kumbaga, from here, hindi ko napakita yung buong derivatives? Yes. You can just say, copy the second, copy the second, derivative of the first, which is A prime, okay lang. Copy the second, derivative of the B prime, yes. Pwede hindi nyo nadaanin yung derivatives nito mga to kasi eventually, it will cancel out. Dahil take note, di ba yung original problem natin is parang lagi magkakaroon siya ng counterpart on the other side. Kasi look at this. Di ba from here, nag-differentiate tayo. Is equal to A, X plus B. Lagi tayo magkakaroon ng A, X that will cancel out with the terms corresponding to them. So, might as well skip that step. So, I ended up with this e to the 2t, a prime na lang pinakita ko, tsaka b prime is equal to whatever the answer is. Wala na yung ax, yung b na agad siya. Okay. Now, ang pangit ng form kasi how do you combine all of them? Take note, as I said, the ones on top should be combined. The ones at the bottom should be combined. So, 1 cosine 2t, 0 sine 2t, cosine 2t na lang pala siya. Sa bottom, 0 cosine 2t minus 2 sine 2t, edi negative 2 sine 2t na lang pala. So, from a very, very expanded form, napapasimplify natin pala siya. Can you follow? So again, 0 cosine 2t plus 1 sine 2t, edi sine 2t na lang, 2 cosine 2t plus 0 is 2 cosine 2t. Now, take note that here, the one on top is partnered with e to the at. Eh di ba ito may e to the 2t rin siya? So pwede kong i-factor out lahat ng e to the 2t so that my answers might be simplified a bit, di ba? The process in answering it might be a bit easier. So, e to the 2t, kinancel ko na. Okay. Ang matitira na lang pala, a prime cosine 2t, etc., is equal to t negative 1. Now, what should be the next step, guys? After this, the Kramer's rule. So, from here, Kramer's rule. What do you call this type of matrix pag nakaganto siya? The augmented matrix. Very good. So in here, again, in order to solve for A prime, substitute natin sa column that contains A and then copy the B. Pero at the bottom, it's the original matrix. So here. So 2t cosine 2t plus sine 2t all over 2 cosine squared 2t plus 2 sine squared 2t. You'll notice that when you factor out the 2, cosine squared plus sine squared is actually equal to 1. That's why in here, that's basically 2 times 1, right? So 2 over 2, you can simplify to have that form, and then 1 half sine of 2t. But take note, this is a prime. So to solve for a, it's basically the integral of that with respect to t. So wala na tayong problem kasi this one is basically 2t over 2 sine 2t pag sinimplify nyo. Let's solve. So again, a is the integral of t cosine t plus 1 half sine of 2t dt. So in this case, you have t and cosine t. How do you integrate this, guys? What can you say about the first term? It's a combination of t and cosine. So if that's a combination, what happens? A combination of algebra and trigonometry. So I can say that, remember this, leate. Diba that's the mnemonics for integration by parts, right? It's not cosine t. May mali pala akong right. Thank you. Yan. Combination of algebraic, and trigonometric. Therefore, let u be the algebra part. Diba? T. And then dv cosine of 2t. So du is dt. The v is basically 1 half sine of 2t. So for the first one, uv minus the integral of v du. This is the first term. Eh di ba may plus tayo na integral of 1/2 sine 2t dt. That second term, right? So what happens is you're left with t over 2 sine 2t. Kaya, ito na lang yung sagot. Now, for B, di ba? Solve for B, it's roughly similar. So I won't show that anymore. So you'll end up with this over this. So again, the A remains the same. The B column will be replaced by the ones on the right. Okay. So let's combine A, di ba? And then B is this. Take note that A is t over 2 sine 2t. B is negative t over 2 cosine 2t. So let's combine that with this. You'll end up having that line. Pinagsama ko na 1 cosine 2t plus 0. We're actually lucky, guys. You're very lucky because the numbers that we were able to get are laging may isang 0 akong nilalagay. So that isang term na lang ang natitira lagi. 'Di ba? Look at the roots that you were able to get. 1002. So laging may isang number lang siya. Mahirap pagka parehong may number 'yan. Kasi pag parehong may number, the answer would be very, very long. Okay? So here, cosine 2t na lang pala matitira sa A. Dito sa B, cosine 2t sa itaas, sa ilalim negative 2 sine 2t. Sa B, ang top is sine 2t, the bottom is 2 cosine 2t. Ayun lang. Look at that. And then multiply by the A and B. So you multiply to both top and bottom, you'll end up having this as the answer. Okay? Pero you'll notice that both of them, guys, have t over 2. So ginawa ko na lang, I moved out the t over 2 to partner with this. So this is your xp. But xp, di ba? You'll notice that you can still combine them pala. Kasi dalawang terms pa siya eh. Ay, ba't ganun? Nung kinombine, naging 0, 2. Eh di mas maganda, it's a lot simpler. It became 0, 2. 0, negative 2, by the way. So, your final answer is xc plus xp. Remember? So, xc plus xp. Therefore, your final answer is this. Again, question, how do we get the values of C1 and C2, guys? You should have initial conditions given. Otherwise, if there are no conditions, we won't be able to solve it.